Thanks, everybody. So my name is Joe Fernandes. I lead the OpenShift business here at Red Hat. My background's on the product side. So 10 years ago this fall, I was working on the first release of OpenShift as OpenShift 1.0, which we released at the first AWS reInvent. So it'll be a 10-year anniversary for both OpenShift as well as the reInvent conference this fall. 6 years ago, I was in Seattle with Diane at the very first Commons gathering. And it's just amazing how far we've come both as a business, as a product, and as a community. And I think Diane has a lot to do with that, so I'd like to give her a round of applause. Thank you so much. I know we've had a lot of sessions today. To put it in context, people always ask me, what are you doing from a product roadmap perspective? What are you doing from a strategy perspective? I'm like, how much time do you have, right? But if you think about it, there's really three things, and you've heard about all of them today, right? First thing we're trying to do is make a product that can run consistently across a hybrid infrastructure. You're all managing a hybrid infrastructure, your developers are consuming that infrastructure, and you heard about today the work we're doing around data center, around cloud, around edge, x86, ARM, mainframe-based systems, fully managed, self-managed, full clusters, single node clusters, hosted control planes, embedded devices and so forth. So that's a big aspect of our roadmap is how do we run consistently across this increasingly hybrid infrastructure that you're all managing. The second is how do we help you bring workloads onto that infrastructure? Everybody knows that OpenShift, that Kubernetes is a great platform for cloud native applications, and in fact the de facto. But we want to be more than that, right? We're trying to be a great platform for stateful services, as our forward speaker, Satish, described. We want to be a great platform for data science, for AI, for machine learning, and you saw many examples of that today. And we also want to help you modernize the millions of applications that you already have in-house, and in many cases have been around for decades. So things like the conveyor community were around application modernization and migration to a cloud-native environment. And then third, we're trying to help you, better build, deploy, and manage those applications across that infrastructure. So things like all the work we're doing around automation, around pipelines, around GitOps, around building developer experience and IDPs, around managing across this hybrid environment, across all these clusters, and certainly around securing all that, securing not only the clusters and the applications, but the entire software supply chain. So if you think about those three pillars, hybrid infrastructure, the hybrid set of applications that run across that infrastructure, and all the work we're doing to help you build, deploy, manage, those are really the three things that drive our strategy. So we have a team of experts that know way more about this here than I do. We always conclude with this session. We're happy to take your questions. So I think at this point, if you have a question, raise your hand. And if I can't answer it, somebody here will be, will be able to. So.
All right, what new feature do you guys really want that you have this opportunity to ask them about? All right, everybody wants a drink first. All right, wait a minute. We have some really cool swag. Someone will ask a question here.
All right, we got one in the front.
Yeah.
Okay.
I can ask any question.
Any question you want.
Okay, hi, this is Vinesh. I'm an OpenShift administrator. My question is for Annette. So you were talking about the disaster recovery operator. So how does it deal with the image replication, the container registry? How does it deal with the replication of the image? Because when you take an application from one cluster to another cluster, the second cluster where the application has come to doesn't have any connection to the first cluster's image registry. So how does the OpenShift operator for the disaster recovery deals with that?
I think what you're saying is how does it restore the application on the alternate cluster?
Yes, with the same image. Yeah.
Yeah, so it's going to be, you would have created it from a Helm chart or from some type of GitOps on the original cluster. So it's just going to redo that. And you are assuming that the image downloads will still work from the CDN or wherever they're coming from.
But what if the first cluster is already down because of the disaster?
Well, if the cluster's down, then what you're doing is you're restoring to a cluster that works. So if the cluster, like I said, the hub cluster in this case is considered to not go down. So it's the hub cluster that's actually connecting and restoring the application to the other managed cluster.
Okay, that answers my question. Thank you. Yeah.
Right.
Just want to add one more thing. We have a feature called OC Mirror. where you can also mirror your OC content locally. You don't need an internet beyond that. So if your cluster is destroyed, you can still have the local images of all the operators and all the container images that you're using. You can mirror it locally as well. So.
Okay. Yeah. Thank you.
Is compliance operator going to stay after the advanced cluster has been in place? ACS in place, right? What is the life
Compliance
of
operator?
the compliance cluster? Would the compliance cluster operator will be staying there?
Yes, so compliance operator will stay part of OCP platform. The only thing that we're doing, we integrated to ACS, so we will get more capabilities in ACS, but we keep adding features to compliance operator. It will be it's our major compliance tools for OpenShift, and we're expanding it to other platform also. So it's still
There
big.
are too many overlappings, right? ACS versus compliance operator.
Yeah, we are working on it to fix this. Yeah, but we want compliance operator to be a central part for compliance. Yeah. Thanks.
Hey, 2 seconds. I think there's a question on the far side.
Hello, this is David. So, there is any plan to add visibility on the operators and which operator needs to be updated, and like just to make sure that like now with this cluster, many clusters being deployed, just keeping track of which cluster have certain versions of certain operator and that all of them follow, like we can just keep like, or dev and QA clusters have certain version of the service mesh or something like that.
So the question is basically keeping track of what versions are running across clusters and across operators within each cluster, is that?
Yeah, like you go to the cluster view and you see like all the versions of OpenShift, right? So if there is any plan to integrate something similar to city operators.
Yeah, I mean, I think partly in terms of how we architected OpenShift itself, leveraging the operator model and the operator lifecycle manager, it's to facilitate that because all of these technologies are iterating on their own schedule and their own release cycle, right? And we want to enable that while also bringing it together.
Yep.
And then a big part of that is the work we're doing around cluster management as well as the work we're doing around telemetry, right? So cluster management, ACM, and some of the new things that we're working on like KCP and so forth is around how do you manage across the multi-cluster environment and manage all the components of that multi-cluster environment. And then the telemetry for folks who have enabled telemetry is about how do we get data back to sort of help be more proactive in identifying issues before they impact you or give you insights into what we see happening across the fleet. But I don't know if you anything else you'd add.
I think I partially heard the question. Sorry, the mic is kind of.
So it is more like, for, let's say that you have OpenShift logging, and before OpenShift logging you need Elasticsearch, right? So many of those times you want to do that upgrade path manually because you need to upgrade first Elasticsearch and then logging. So that's why I have manual installers, or because like for example last week the advanced cluster security just broke something on the vulnerability. So I keep all those operators being manual subscription. So I manage those myself, but then it's just like you need to go back and change that at some point, right? And you want to test that manually.
Yeah. So, did you want to do this? Yeah.
So are you asking about, if I understood, across multiple clusters? Like some clusters fall in one category? Yes, I think ACM is exactly the right answer there. The policy and governance features there are designed for that sort of thing. Whether it's you're going to enforce that this group of clusters has a subscription for an operator from a particular channel, maybe production grade channel, some other collection are using a more forward-looking channel, or if you're handling those operator installations more manually. Either way, I think those policy features of ACM are the best way to accomplish that across many
and that's
clusters.
fine, and that's what I thought, like you keep the subscription on certain version, but then it's like you don't have a way to know that there is a new version unless you go to operators. So that would be something cool to add in something like that.
Visibility into
Yes.
Yeah,
Yes.
Operator availability and upgrade paths.
Correct.
That's good feedback.
Thanks.
Also, before Just to be clear, ACM, the operator for ACM didn't break. There was a policy that was
No,
pushed.
I know.
We want to be crystal clear.
No.
The operator does not break, all right?
No, I know that. We got a hold of that real quick, and support was amazing, giving us a solution like the ticket took 2 minutes to be resolved, but still, like, it was something that happened automatically because that operator was set to automatic. So, yeah, thanks.
Thanks for
Thank
the
you.
question. So we have a question right here.
Oh, okay.
So I also have a question about the operator hub and all the operators. Will there be some a better possibility to do lifecycle management? For example, if you want to ensure that you have DTAP and you first want to ensure that an operator it works correctly, to pin down the version in the channel for a specific environment.
That's on it.
So you want to pin the version to of an operator to a specific cluster or a specific namespace? Or, I mean, namespace is not.
No, I mean like first we want to test it in D, T, and A before we go to production, but there might be possibilities that there is already a newer version available in the channel, and when we sync the channel on production, it might be a newer release than what we have tested. Okay. So would there be a better way of lifecycling?
I mean, you can, on different clusters, choose to have the different versions of the operators and subscribe to different channels. And I think you can even pin and say that I want to go to a previous version of the operator. We can pick by version number.
But if you do latest, you always get the latest, and it's more like on a syncing level. Can we ensure that on production we are never ahead of the dev test acceptance?
If you really want control over it, you can go into a disconnected mode, so you have full control of what versions are available in any environment, so that latest really isn't latest like upstream. You can then go ahead and have a curated set of what latest means for your organization.
Yeah, and you can use Mirror to download that set of operators.
I guess I have to talk to him.
Yeah, check with Andy afterwards, but yeah, the whole, once you disconnect from the channel, and for customers that are running disconnected, this is sort of a fact of life, then you're sort of controlling the content that you're feeding into the cluster. And so latest means, as Andy said, the latest that you've given the cluster access to locally. Yeah.
All right. There's another question over here.
David here. It's about microshift. What is the advantage or the main advantage over the micro K8s or the K38s?
Yeah, so I'll give this to Frank in a second, but just real simple, why did we build microshift to begin with, right? Like as we push out to the edge, obviously infrastructure constraints are infrastructure is the big constraint, right? So we continue to shrink the footprint down to 3-node clusters, to single-node distributed clusters, to then single-node OpenShift, but you're still dealing with edge servers, right? At the edge, there's devices, not just servers, right? So microshift is really getting into that edge device space, and that's why the productized version of microshift is Red Hat edge devices and so forth. I'll be honest, it was inspired by some of the work we saw in the community, including K3S. Frank can talk a little bit more about why we didn't go that route and what some of the differences are, but yeah, it's really getting into the edge device space.
Okay, thank you.
So I could make my life easy and just say, it's all different distributions of Kubernetes for the small footprint, right? K3S branch SUSEs and micro-Ks canonicals, we have microshift. But I would like to point out that there's also a different focus, right? Because if you look at some of the other distributions, what you will find is that their focus is actually on the small footprint, in some cases like running on as many platforms as possible, right? Running on this Linux distribution or that Linux distribution, and being able to install very simply on those. And if you think about it, it's a developer use case, right? And one difference is that from the very beginning we said, for us, we want to solve the production use case on those edge devices. And as a consequence, we made a lot of different design choices, right? Because we want to preserve these qualities that I mentioned during the talk. We want to integrate very well with the operating system. that is designed for that use case. So that was one of our design goals. We wanted to keep preserve the qualities of OpenShift, right? So you deploy on cloud, you then push your workloads to that device edge. We wanted to keep that security posture, right? That, if you want, the SE/Linux of Kubernetes part, right? So our design decisions were very different because we are targeting that edge device production use case and not a developer use case. Does that make sense?
Yeah, thank you.
Thank you.
Yeah, what's amazing too about all these footprints, right? We don't know what all people are going to be running when you think about data center, public cloud, edge servers, edge devices. We don't know all the different use cases and workloads you're going to be running there. But we do know one thing. You're probably going to be running Linux there. If you're running Linux there, it's going to probably be packaged as Linux containers these days. And then increasingly, we're seeing Kubernetes show up in all these environments as well. And that's why we as a company need to be there, but we need to be there all the way through like the production requirements that you'd need to run that at scale in mission critical environments. So. Yeah, go ahead.
Real quick on MicroShift. I did a MicroShift demo at a Red Hat user group, which I recommend you should all attend if you can. And the easiest thing about it was I installed a couple RPMs. I had a YAML manifest where I created a namespace, a deployment, a service, and an ingress, and a DNS entry that was already created, and I curled it, and I hit it from my laptop, hello OpenShift. I didn't have to worry about learning traffic. I didn't have to worry about installing another CNI. I didn't have to do anything. It was a RPM and a YAML manifest, and I was up and running in seconds. I literally uninstalled everything, rebooted the machine, and we did it together, and it took about 5 minutes, and the entire user group was in shock. The fact that it was that easy. You can't do that with K3S. You can't do that with K0S. You just can't do it. And the best part is we're going to sell it and we're going to support it. So that's another thing you have to take in consideration.
You have a question right up front?
This is an OKD question. Just wondering I'm a little confused where the relationship between upstream and downstream between OpenShift and OKD.
I think a lot of people are. Right, there's a lot of chuckling behind me about this. So it's been referred to as a sister distribution in a lot of ways because the components are the OCP components, right? They get pulled down, but it runs on Fedora CoreOS as opposed to Red Hat CoreOS. And some of the operators are not there, and obviously the support model and whatnot. It's been, because it was on Fedora CoreOS, there wasn't sort of a clear path to get into OCP from things happening in OKD, and quite frankly, also there wasn't as much community involvement, right? Ideally, that's going to change, and ideally with the changes that we talked about today, both technical and community-wise, we will see things actually start filtering from OKD into OCP, right? But that's going to take these technical changes and the community getting involved to really say what do they want, right? And to get that tested and to polish it up and make it something that can be incorporated into OCP.
Yeah. Well, and just to speak about the relationship a little bit too. Like to the point about the relationship as well, and like there are some of us who are Red Hatters, OpenShift engineers who are also involved in the OKD community, and so like my personal feeling on this, right, is like right now OKD is kind of consuming the downstream from OCP, right? But I would love to see a world, even as an OpenShift engineer, where we're pushing more of this knowledge out into the community, like we do with CentOS, right? And so one of the reasons I love participating with that community is because there is a desire to understand how to contribute back to OCP, right? And right now the community doesn't understand, like, if I find a problem in OCP and maybe I fix it, how would I contribute that back, right? So a lot of the development that's happening internal to Red Hat, we're trying to share that. We're trying to let people know, how would you find a bug, and then how would you report that bug back to us? And if you fixed it, how could you get it to the right team so that it could get included? And so right now we're still, OKD is consuming OCP, but if we can build the community like we've done in Fedora and CentOS and whatnot, then there's the possibility that we could grow to this relationship where there's like, we're consuming it at the tip of master, and then we're sharing back and forth, and people from the OKD community understand how to bring a bug report back to Red Hat, how to create a patch so that eventually it can get included in an OCP release. So like for me, this is where I'd love to see us go. You know, it's a question of will the community get there and can we do it? You know, so that'd be hopefully working. Oh yeah, oh yeah, sure.
Thanks. And hi, you didn't see me here today, but I'm the Karsten Wade. I'm the community architect for Operate First. And what I wanted to do was to go off what you mentioned. Mike mentioned Fedora and CentOS, right? And that's not just a casual reference. There's a history here, and I think people jokingly refer to me as the keeper of open source lore at Red Hat. So that's what this is. Back in the days, the Fedora build system was internal to Red Hat. And for the first 6 releases of Fedora Core 6, you couldn't touch the build system. There was nothing you could do but create some packages outside, and that was Fedora Extras, and that's what people did. So when the build system called Koji was created in the community, and the tools that went along with it were better developer experience than what people had inside of Red Hat with that system, it was the draw to the developers and then the draw to the business to bring it all together in the community space. And so that's why it got renamed to Fedora 7 at Fedora 7 release, is because there was no longer a core that was inside the company, the build system was outside. So effectively, where we are today with OKD is right at that first step of having a build system that's external to the community. And the analogy matches up 100% from there in terms of going from this kind of sister cross-stream thing to actually being able to build an upstream in a way that makes sense for all the people who are invested and care about it, who are standing here on the stage and who are sitting here in the audience.
Question in the back?
So this is about Microshift. Just kind of a bit of it was already clarified earlier, but in particular, I wanted to ask can Microshift nodes be clustered similarly to like K3S or K0S nodes? And then kind of a more general question, is there a list of, or a possibly published document saying exactly what the design goals were as opposed to some of these other systems? I understand it's production OpenShift, but is it intentionally just one single node, or is that subject to change? Or
I mean, I'd say from a business perspective, it was really targeted at that edge device IoT gateway. That thing. Like we couldn't shrink the OpenShift footprint small enough with everything that comes with it, OLM operators and so forth. You know, to get down beyond a certain size, right? That would sort of fit an edge server model, but not an edge device model. A challenge from the business perspective is if you guys grow it back and now we have sort of 2 parallel streams of OpenShift, that's not what we're going for, but now I'll let Frank answer.
So I alluded to this earlier, that it's super important for the Microshift team, but also I would argue for the other teams in Red Hat, that we just don't build anything in the open air. We need to anchor it, right? This is why we work with partners, like for example, Lockheed Martin, to actually understand their requirements. And the reason why we're like single node at the moment is because that's where the demand is. And we're basically going to prioritize exactly based on the customer demand. So if you want to know more about the design principles, please visit github.com/OpenShift/Microshift, which is the GitHub repo where all the code and everything is. There is a documentation folder that also contains the design.
Well, is it too early to ask when OpenShift 5 is coming?
Yes.
And also,
I think over my dead body is one of them. Just kidding.
And also, what are the major changes that come into OpenShift 5? Because I noticed that from 2 to 3, 3 to 4, there are always big changes, right? Thanks.
So I'd say a couple things. One is we don't take major releases lightly. We know they're very disruptive to you as customers and certainly to us as a business, right? The things that have driven our major releases have been sort of major re-architectures of the underlying platform or infrastructure that surrounds it, where we had no other choice, right? So obviously 2 to 3 was obvious when we did that in 2015. OpenShift 3, we pivoted everything, right? OpenShift 2 was actually built in Ruby, based on Linux containers, but it was our implementation of containers. There was no container standard. OpenShift 3, we now had Kubernetes, we had standard containers with Docker, which became OCI, and so forth. So that was sort of a clear pivot. Some people even thought maybe we should have renamed it something else because it was completely different from the ground up. 3 to 4 is basically the pivot around going immutable at the infrastructure, at the cluster level, right? So RHEL to RHEL Core OS, bringing in the operator model. The cool thing is the workloads didn't change, right? Like Kubernetes itself was still the basis, and so we just sort of, the next version of Kubernetes became the basis for OpenShift 4. The containers that you were running in V3 came forward to 4. So we didn't change the model for the application, but the model for how we built and deployed and managed clusters is the same. Kubernetes itself is still on 1.x, right? The same, 1.0 launched in 2015. I think we're up to 1.2.3 or 1.2.4. Right now, I don't see like a Kubernetes 2.0 on the horizon. That would be one thing that would potentially drive a major release, is if Kubernetes itself evolved major. From the platform, and again, any of the PMs can tell me I'm wrong, but from the platform right now, we don't have any plans for a 5X. We're essentially iterating on the current platform, both in the Kubernetes community and these surrounding communities. And moreover, most of the innovation now, the rate of change is much faster in the projects above and around Kubernetes in the CNCF ecosystem. Kubernetes itself is really focused on stabilizing and minimizing change in that core. So no plans for an OpenShift 5 anytime in the near horizon. Never say never, but yeah.
There's no reason right now.
Yeah, exactly. There has to be a reason, and right now we don't see sort of a reason for that. Even like new footprints like Microshift, we developed that as a sort of a new distribution, right? Like around the edge device model versus sort of a major upgrade. And I think that's a relief to a lot of customers. We're still migrating customers from 3 to 4, right? And we will be probably for the next year. So,
it should be a quick question. I heard that, and maybe I misunderstood, but they switched from Fedora Core to CentOS Core. Is Fedora, Red Hat's view of Fedora and its future going to change at all?
No. So I'll give you my take on it. These guys can add. When you looked at OKD, or what was previously called Origin in the 3.x days and prior, right? We built OpenShift or OKD on top of CentOS, right? And that was good. CentOS gave us a stable community distribution of Linux, and then we innovated on top of that. There's one problem though, right? A lot of the innovation is in the container runtime itself, right? So the fact that CentOS was upstream from RHEL means that we weren't getting the community benefit of innovating in RHEL. You go to version 4, and now we have RHEL Core OS. There was no CentOS Core OS for us to build on. We did build Fedora Core OS. That creates a problem. So now we're upstream, but we're very far upstream, right? So Fedora, it's building on the latest version of Fedora, which won't be part of RHEL until RHEL 9, because RHEL doesn't rebase to Fedora. So with this OKD stream, a key benefit is the whole platform is upstream of our commercial distribution, but it's more close to the actual community distribution, so we can experiment with the entire platform from the operating system runtime on up, but also do that in a way that feeds directly into our commercial products and our productization process. So I'd say what happened with CentOS streams is essentially the equivalent on the RHEL side, with that becoming upstream to RHEL. So.
And just to clarify, there still will be OKD on Fedora Core OS available. So it's not actually switching from one to the other. It's actually an option that's going to be provided to the community. Yeah.
Yeah, I would just add one more thing. There's a reason there's an S on the word streams.
Right.
We envision a number of different bespoke OKD builds depending on the project or experiments that you're running. So the Fedora Core OS, there will be things out there. Oh, absolutely not.
absolutely not, yeah.
Can you imagine if
Yeah.
I tried? No, not going to happen.
Transplant surgery,
Yeah.
everything all at once.
Yeah. RHEL 9 is building, getting ready to release as we speak. RHEL 10 will be based on a future version of Fedora, and we'll continue to have the Fedora CoreOS distros as well. So,
All right, are there any other questions? Oh, there's one last question here, then we get a break. So here, go for it. You get the final.
So just as an example, right, if there are hundreds of these microshift deployments, can like ACM manage them?
that's a great question, right? So like two of the big things around Edge that we had to solve for, one was the constrained infrastructure footprint that we had to run on, and two is how to manage a lot of these instances at scale, right? So the first thing is we needed a multi-cluster management solution, not just for Edge, but for even traditional deployments in the data center or across the public clouds. The next thing we need to do is, scale it, right? So we've done a lot of work, both at Red Hat. We've actually gotten help from IBM research on this around scaling ACM to be able to manage, thousands of clusters, and we really need to keep driving that into tens of thousands. So that's a big focus. And then when you look at kind of related technologies, KCP, Hypershift, and so forth, it's hub clusters and so forth. That's just continuing to drive on that scale. So yeah, absolutely, we are working on it, and we continue to work on it because we need to be able to have a strong multi-cluster management solution to manage the growing number of clusters out there, particularly at the edge where they scale really, really fast. So, all right.
All right.
Well, thank you all, and thanks all for coming. Thanks to our presenters. That was fantastic.
Okay.